Hi, this is Rick for EDU Mobile. In this demo, we're going to look at the life cycle of an application. This demo is called Hello Lifecycle, appropriately enough, I guess. First, we're going to look at this Androidmanifest.xml file. We can see that this is an XML file. It's just got the standard XML header, version 1, UTF-8 for the encoding, and it has a single root node, like a well-formed XML file should have, and that root node is manifest, and we can see closed manifest here. It tells us the package level, the name of the package, com edu mobile hello lifecycle.app, and then in the application section there is everything regarding this particular app. So we have allow backup true, the icon in the drawable IC launcher area, the label is Hello Lifecycle. The theme is the in style app theme, and then we have the activity. Now, this application has only one activity. If it had multiple activities, it would have multiple activity sections in this application section. The name of this activity is com.edumobile.hellolifecycle.app main activity. The label is Hello Lifecycle for the activity, and then we have a section called Intent Filter. An intent filter is what intents this activity will respond to. Now, we have an action in this activity, in this intent filter, I should say, that is named Android.intent.action.main, and its category is Android.intent.category.launcher. This tells us, the intent filter tells us, that this activity will be executed or run when a launcher icon for this app is touched. So when we have the category of launcher and the action of main, that means that this activity will be the entry activity or an entry activity of this application. Okay, so that's a little look at the Android manifest. If we add new activities, we must add these activities into our application section. Likewise, if we have anything that responds to an intent would need to be added in here. So services and broadcast receivers as well would need to be in here. Content providers also need to be in here, but in a slightly different way. And we'll get to that when we get to those different pieces or components of an application. So that's the Android manifest file. It is located here in resources. So let's look at the code for this app. We can see after we've got our imports, and I'll close that down. So after our imports, we see that we have a class named main activity, which extends action bar activity. Action bar activity is a subclass of the activity class. Now, we see this annotation here, override. This tells us that we are overriding a callback of the activity, or a method that exists in the activity class, or the action bar activity class. So we have onCreate, which we talked about. OnCreate is the only callback method that takes a parameter, and it takes the saved instance state. Now, this is a bundle. What this is the state that the application is in the last time it was exited. So if we need to save state, we would normally do that in the onPause method, and I'll tell you why here in a moment. It'll be very obvious why we would do it in onPause in just a moment. Okay, so we've overridden onCreate, which is by default, this is already overridden in the template code for an app, and we've logged out that this is coming from main activity, and we're just sending onCreate called, and this will send this log to logcat. Now, there is a class named log, capital L, and there's an instance or a class method called I, which is an informational log. So by typing capital log.I and then where it's coming from, or a tag value, and then a actual log statement value, we can log out to logcat. Logcat is probably the single most useful debugging tool we have at the early level when we're simply trying to figure out what's happening, when methods get called, and so forth. So doing that, the Android Studio will find that log class and import it for you. So we can see that android.util.log has been imported. All right, so likewise in onStart, we've logged out onStart called, onResume, logged out onResume called, and each of these methods we've logged out where we're calling from. Now notice that each of these methods overrides its superclass's method of the same name. So our class name is main activity. The action bar activity is its superclass, and then really these are coming from the activity class. So we always call through to super when we call one of these callback methods. So super on create with its parameter, super on start, super on resume. We must do this. If we omit this when these callbacks are called, there will be an error and your application will crash. So we're going to go ahead and run this, and I want to show you how to get to that logcat. So when we run, we're going to see that first of all, Gradle is going to compile the app, and then it's going to tell us that that process is completed. It will ask us to select a device. In this case, we're going to select the emulator that's already running, and then the application will run. So it asks us now to choose a running device. We could also launch a new emulator by choosing this selection, but we already have a device running, emulator iPhone, Android, and this device is using just a kind of default virtual Android device. So we're going to go ahead and tell it that's okay. I'll run it on the existing emulator. And then I'm going to pull this section up. The one that we are interested in here is devices logcat. We can see that these are the various processes that are running on the emulator. And now when we open up the emulator, we can see the application actually start to run. Now it takes some time to do this. There is some overhead, but here we are. We have the Hello Lifecycle app running, and Hello World has run. Now let's see what has happened here. We've got these log statements, and we can see that really we're only interested in three things that have happened: on create, on start, on resume. Now logcat can get a little bit noisy, but we can filter it. So if we filter it by log level info, we will only get these log.i statements. There is an info log here that we're really not interested in, surface of trib not implemented, so we can further filter this. Every statement that I've had here that we're interested in looking at contains the word called. So we can filter this on anything that contains the word called. So now we have on create called, on start called, and on resume called. Now that's what we would expect. So remember that on create, on start, then on resume are called in very rapid succession. On resume tells us we're going to the resumed state, which is an active, interactable state for that activity. It's the only one we have. Now look at the timings. We have a very short amount of time between on create and on start. So we're in a created state from 4:16 to 4:36, about 20 milliseconds. And then right after on start, on resume is called. In fact, in the same millisecond. So, okay, so now let's do something here. Let's press the home key on the screen. The home key puts the app in a stopped state, but it doesn't terminate the app. So let's go ahead and press the home key, and let's see what happens. On pause is called, and then on stop. And we can see that there's a significant amount of time here. In this case, it was about 4 seconds between on pause and on stop. So if we wanted to save state, we would save it in on pause because we have a lot of time to do so. So let's see what happens when we resume the app. Now, on stop has been called, but we haven't actually killed the application because we pressed the home key, not the back key. So now let's go ahead and reopen the app, Hello Lifecycle, and we can see that after on stop, we have on restart, on start, on resume, just as we would expect. And of course, if we press the back key, the app will terminate. On pause, again, for a very long time, on stop. All right, the one thing I forgot, and I apologize, we should really have an on destroy in here to see when that happens. So let's go ahead and copy this and change this to on destroy so that we can see that. And we'll grab this, copy that, and say super on destroy, and on destroy called. All right. So now it will save that and rerun the app, and we'll see these destroy calls as well. Now the destroy call will only happen when we press the back key. So here we go. We're running again. We see on create, on start, on resume. The home key gets us back to on stopped, on pause, and then on stop will be called. And then we'll relaunch the app, or actually restart the app, on restart, on start, on resume. And then finally, closing the application gets us on pause, on stop, and finally on destroy, so that we know that the application has been removed from memory. Thank you very much.